any advice you would like to give a up-and-coming data scientist who'd love to one day be a lead data scientist within an organization?
I think as a aspiring data scientist, whether you're young or old, but aspiring, you might have moved from one area into data science and you want to be successful. I think learning to listen is your first job. Learning to understand, or listening to understand. Stop thinking too much about what programming language you're going to use. Don't worry so much about modeling techniques or modeling algorithms. What you can do with a random forest, you can do with the XGBoost, and you can do with the light GBM. The key to success is framing the problem, solution, and then only putting it in place. First, framing the problem properly. Decide very carefully what you are going to do for the user. Interrogate the user. Ask them, what exactly are you going to do? Literally, what are you going to do when I give you the predictions? What are you going to do with that? Where does that feed into your life? What does your process look like after I've given you my solution data, my answer, my prediction? Tell me about your process. Ask these questions to the client. Learn how to ask them, but also learn how to listen. Then on the other side of the coin, in your left-hand brain, understand modeling deeply. What is modeling? What is predictive modeling? What are these models capable of doing? Interrogate the outputs like you found a giant gemstone and you want to understand every single aspect of it. I used to tell my students in regression modeling, once we've fitted a model on this tiny data set that we used to use, or all the data sets were tiny back then. I used to tell them, now you have your $1 million thing. We've fitted the model. Here's the thing you paid money for. You paid money to run an experiment. Now you've trained this, or fitted. We didn't say train back then. You fitted the regression model. That model is the answer to all of everybody's questions around this piece of equipment you've been testing. It's worth money. Now look at it. So we went into this whole next level diagnostics of the model to interrogate that model and see what it is actually capable of doing. These days, machine learning specialists and data scientists, they look at one metric. Their biggest question is, should I use the root mean square error? Should I use, for classification model, should I use accuracy? Or should I use a Gini curve? It shouldn't end there, folks. You need to go and see how that model performed on your data in detail. You need to look at the residuals. You need to look at how they behave. You need to check whether your model is equally good over here and then it is over here in your data. How does it behave against the different features? How does it behave against the predicted values? Go and look at an old stats book and see what diagnostics they run on a regression model. Why aren't we doing it on machine learning models? I don't know how many times I've found data problems in our own pipelines using proper machine learning models by looking at the residual plots. That is a piece of advice I can give, technical advice. Interrogate your model, understand it. Don't just train it and drop it somewhere and deploy it.
I can almost see you screaming, this is a 100 million rand model.
Yeah.
It's affecting the business. Why would you not spend time just to really understand what's going on here?
Exactly. And then you can start to understand, what does root mean square actually mean? Is it just a number? No, it isn't. It has a meaning. That's one of the metrics that has a very, very applicable meaning. So go and understand those bits. Learn how to train a model. Learn how to work out complex features. Understand time-related features, those things. This is where your brain is needed and no one else can help. The business person is not going to do that for you. They won't be able to. They can't write complex SQL queries. You got to do that. Who's going to train the model using the right setup, with the right parameter tuning, with the right feature selection methods, those things. Those are the powerful parts of a data scientist's arsenal that can really drastically increase the accuracy of the model. Very good feature engineering, but think, what is the connection? Think about what is the connection between my features and the predicted response. What does this model actually do inside? Go and understand the tree models, how they're built. Go and think of your own explanation as to why XGBoost might be a more stable approach than just doing a single regression tree on your data. Why is that so? Understand why that's the case. When you get a deeper understanding of what modeling really is, and forget about the Python versus R conversation and the packages you use, and whether you should plot using Plotly or Seaborn or whatever. You're needed in the thinking space, and you're needed in the understanding the model phase. No one else is going to do that. So remember, your purpose as a data scientist is to provide a good and trustworthy model, and to be able to show how you got there. And in the background, you need to understand what's going on.
100%.
So don't just go to Stack Overflow and pick a script now and copy paste, and that's your solution, give it to a client.
Oh my goodness.
That's very risky.